4.8 lesson is going to be working with imaginary numbers. So please write down, if we have the square root of -1, that is just what I is, our imaginary number. Okay, if I were to square both sides, then the square and the square root on the left-hand side would cancel out, so I get -1, and then if I square it, I get I squared. So I squared is just -1. So as we go through, we'll just want to keep these in mind so that anytime that we have a square root of -1, it's just I, and then anytime that we have I squared, we can plug in -1. Okay, so for this first example, we want to just talk about how we simplify radicals. So think back to elementary when you had to do your factor trees. So if I did my factor tree for 32, I would get 2 times 16. And then 16 is 4 times 4. And 4 is 2 times 2. And the other 4 is 2 times 2. So if I were to write this all out, I would have 2 times 2 times 2 times 2 times 2. Then if I multiply those all together, I get 32. Now, since it's a square root, I need to bring things out in groups of 2. Okay, so I have a pair of 2's here, I have a pair of 2's here. So I bring this 2 out and I bring this 2 out. Now those numbers that I'm bringing out, I'm multiplying those together. So I have 2 times 2, which is 4. And then this 2, I don't have a pair with it, so I leave it underneath the radicals. So that would be my final answer, 4 square root of 2. Now this next one, I have negative square root of 18. So I'm going to just put -1, and then 18 is 2 times 9. 9 is 3 times 3. Okay, so I have a pair of 3's, so I can bring out a 3. I have square root of -1, which is just I, so I can bring out an I. So then I have 3I, and then this 2, I don't have a pair of it, so it's just square root of 2. So that would be my final answers, 3I square root of 2. This next one, again, I have another negative underneath, so I'm going to want to put -1 times 12, which 12 is 4 times 3. 4 is 2 times 2. So I expand it out. Square root of -1 is just I. I have a pair of 2's, so I can bring out that 2. So then I have 2I on the outside, and then this 3 doesn't have a pair, so I leave it. This next one is square root of 108. So I do my factor tree and I simplify it, or I expand it out, sorry. So I have 2 times 2 times 3 times 3 times 3. I bring out my pairs, so I have a pair of 2's, I have a pair of 3's. So I multiply those, so 2 times 3, I get 6. And then this 3, I don't have a pair, so I leave it. So it would be 6 square root of 3. Now, these next ones, we're going to be graphing and finding the absolute value of our imaginary numbers. So if the original problem is -5 plus 3I, I have this graph here. This is our y-axis normally, but it's going to be our imaginary axis. And then this is normally our x-axis, but it's going to be our real number, so our real axis. So if I wanted to graph -5 plus 3I, I'd go over to -5, that's my real number, and then up to +3, my imaginary number. And my graph is just going to be a point. Okay, and then to find the absolute value, I'm going to square both numbers. So -5 squared, 3 squared, ignore the I, just square both numbers, and then you're going to take the sum of them and then take the square root. So -5 squared is 25, 3 squared is 9. I add them together, I get 34, so then it's the square root of 34 for my absolute value. Now let's try another one. So 6I, notice I don't have a real number, so my real number would just be 0, so I'm not going left or right at all. So I just go up to 6 and plot my point. And then to find the absolute value, I square both numbers, so 0 squared plus 6 squared gives me 36. I take the square root of that and I get 6. So that would be my absolute value. Let's do one more of these. So my real number is 5, so I go to the right to 5. My imaginary number is -1, so I go down 1. I plot my number, and then to find the absolute value, I square both numbers, so 5 squared and -1 squared. 5 squared is 21. -1 squared is 1, so 25 plus 1 is 26. I take the square root of it, and that is my final answer. Now we're going to be working with adding and subtracting, multiplying and dividing with our imaginary numbers. So for adding and subtracting, you're just combining like terms. So think of this I just like a variable, like an x. So 4 plus negative 4 is 0, and then negative 3i plus 3i is 0. So our answer would just be 0. This next one, notice how I have a negative here. So I'm going to distribute that negative to everything behind. If I want to, put a 1 here. So negative 1 times negative 2 is positive 2. Negative 1 times 4i is negative 4i. And then I combine my like terms. So 5 plus 2 is 7. Negative 3i minus 4i is negative 7i. These aren't like terms, so that is my final answer. This next one I'm adding, so I just combine like terms. So 7 plus negative 3 is 4. Negative 2i plus 1i is negative 1i, or just 4 minus I. Now this next one is 3i times negative 5 plus 2i. Since I'm multiplying, I'm going to do the distributive property. So 3i times negative 5 is negative 15i. 3i times 2i is 6i squared. Notice I have an I squared, and we had said anytime that we have an I squared, that just equals negative 1. So I'm going to plug in my negative 1 for my I squared. So I have negative 15i minus 6 would be my final answer. Now this next one, I have 4 plus 3i times negative 1 minus 2i. I'm going to do the distributive property, so distribute this 4. I get 4 times negative 1 is negative 4. 4 times negative 2i is negative 8i. And then now I distribute this 3i. So 3i times negative 1 is negative 3i. 3i times negative 2i is negative 6i squared. I combine my like terms. So I have negative 8i minus 3i is negative 11i. And then this I squared equals negative 1. So I can plug in negative 1 for my I squared. And then I keep simplifying. So negative 6 times negative 1 is plus 6. Combine my like terms. So negative 4 plus 6 is 2. And then that negative 11i, I just leave it. These are no longer like terms, so that would be my final answer. Let's keep working on some examples. Getting more comfortable working with these imaginary numbers. So this next one, we're going to FOIL again. So we're going to distribute this negative 6. Negative 6 times negative 6 is 36. Negative 6 times negative I is positive 6i. Distribute the I, so I times negative 6 is negative 6i. I times negative I is negative I squared. These two middle terms cancel out, they're opposites. And then I squared is negative 1. So we have 36 minus negative 1. Those two negatives cancel out to be positive. So 36 plus 1 is 37. The next one, I have 7i times 3i. So there is a multiplication problem. So I get 21i squared. When I multiply these, I squared equals negative 1. So I plug that in. So 21 times negative 1 is negative 21. Now, this next problem, notice I have an imaginary number in the denominator that's not reduced. I can't have an imaginary number left in my denominator. So how I would simplify this, whatever your imaginary number is in the denominator, you're going to multiply by that same term, just the opposite of it. So it's positive 3i, so I'm going to multiply the top and bottom by negative 3i. So then when I do that, on the bottom, 3i times negative 3i is negative 9i squared. On top, I'm going to distribute this, so I get negative 27i, and then negative 3i times 12i is negative 36i squared. Then I keep simplifying it. So this I squared equals negative 1, so I plug that in. This I squared equals negative 1, so I plug in that. So I have negative 27i. These negative 36 times negative 1 is positive 36. Negative 9 times negative 1 is positive 9. Now I can still reduce it, so I want to. Negative 27i divided by 9 is negative 3i. 36 divided by 9 is 4. So that would be my final answer. Now this next one has an imaginary number in the denominator, but notice instead of just one term, there's two. So anytime that there's two terms, you're going to multiply by the same two terms, put the sign in front of your imaginary number, just switch it to its opposite. So very similar up here. And whatever you multiply across the bottom, you have to multiply the same across the top. So we're going to have to FOIL across the bottom and the top. So we distribute. Just a second. My arrows are looking a little crazy. So I distribute this 2, sorry. So 2 times 1 is 2. 2 times 4i is 8i. Now distribute this 3i. So 3i times 1 is 3i. 3i times 4i is 12i squared. Now I distribute this 1. So 1 times 1 is 1. 1 times 4i is 4i. Now I distribute this negative 4i. So negative 4i times 1 is negative 4i. Negative 4i times 4i is negative 16i squared. So then I combine like terms, plug in my negative 1 and for my I squareds. So 8i plus 3i is 11i, and then I have negative 1 that I'm plugging in for my I squared. 4i minus 4i, those just cancel out, their opposites, and then negative 16 times negative 1. And so then from here, I keep simplifying it down. I get 12 times negative 1 is negative 12. Negative 16 times negative 1 is positive 16. Combine my like terms, so I get 2 minus 12 is negative 10. 1 plus 16 is 17. So you'll notice we want to have the same first terms, the same last terms, opposite signs, so they cancel out like they did in this problem. So let's do one more of these ones. So again, we want the same first terms, same last terms in our denominator, just opposite signs, so our middle terms will cancel out. Whatever we multiply across the bottom, we need to multiply the same across the bottom. So we need to get rid of that I in the denominator. So we go ahead and distribute this 5. So we get 15 minus 20i, distribute this negative 2i, we get negative 6i plus 8i squared. Distribute this 3, we get 9 minus 12i, distribute the 4i, we get 12i minus 16i squared. We combine our like terms, so negative 20 minus 6 is negative 26i, plug in negative 1 for our I squared. These two middle terms cancel out, and then plug in negative 1 in for our I squared. So then we're left with 15 minus 26i minus 8, and then 9 plus 16. And then from here, combine our like terms, and we get negative 26i, and then 15 minus 8 is 7, and then 9 plus 16 is 25, and that is our final answer. Now these last couple we're going to be factoring. So to start off with, we factor out the greatest common factor. So both of these we can factor out of 2, so we factor out of 2. And then we have x squared plus 16 left over. Now notice these are the sum of two perfect squares. So anytime that you have the sum of two perfect squares, we're going to take the square root of the first term, that's our first term, square root of the last term, that's our last term. And then notice, normally if our middle term is negative, we would, and no middle term, we just have one positive and one negative. For this one, if we had one positive, one negative, our last term is going to be negative 16, which we want it to be positive 16. So we need to tack on an I for both of those and make one positive and one negative for it to work out. Okay, this next one, we have 5x squared plus 20. So we factor out the 5. We have left over x squared plus 4. Again, it's the sum of two perfect squares. So we take the square root of the first term, that's our first term. Square root of 4, that's 2, that's our last terms. It's the sum, so we're going to put an I on the back of both of them, make one positive and one negative. Alrighty, these last two examples are using that quadratic formula that we talked about, but looking at when we have imaginary solutions. So for this first one, we have 2x squared minus 3x plus 5. Our A is 2, our B is negative 3, and our 5 is our C. So we plug those into our quadratic formula. So we have negative 3 plus or minus the square root of negative 3 squared minus 4 times our A, which is 2, times our C is 5, all over 2 times our A, which is 2. We simplify that down, so negative 3 is positive 3, negative 3 squared is 9, and then we take negative 4 times 2 times 5 is negative 40, 9 minus 40 is negative 31. 2 times 2 is 4. Notice how we have a negative underneath there. So anytime we have a negative underneath the radical, now we know how to simplify it so that we can just bring out our I, and then square root of 31 doesn't have any pairs, so we just leave that. So that would be our final answer. So let's try another one. So we plug these into our quadratic formula. Our A is 3, our B is negative 1, and our C is 2. So we plug that in, negative 1 plus or minus the square root of negative 1 squared minus 4AC all over our 2A. So then we have the two negatives cancel out to be 1. Negative 1 times negative 1 is 1. Negative 4 times 3 times 2 is negative 24. And then 2 times 3 is 6. 1 minus 24 is negative 23. It's another negative. So we bring out our I, and that changes this to positive 23. We can't simplify the square root of 23. If we try to do our factor tree, we have no pairs. So then that is our final answer.